Driving with a low fuel level can be severely detrimental to your vehicle. Modern cars are fitted with an electric fuel pump inside the gas tank that depends on the surrounding fuel for both cooling and lubrication. When you drive on less than a quarter tank, the pump is not fully submerged, causing it to overheat and wear out prematurely. This can lead to a costly pump failure. Furthermore, gas tanks accumulate sediment over time. Running on low fuel forces the pump to draw from the bottom of the tank, pulling these contaminants into your fuel system. This can clog your fuel filter and damage injectors, impairing engine performance and potentially leading to more severe engine damage. Coasting in neutral may seem like a clever way to save fuel, but it is a dangerous habit that compromises safety and can damage your transmission. Automatic transmissions require the car to be in gear to ensure proper fluid circulation and lubrication, which are powered by the engine. Shifting to neutral while moving disrupts these vital functions, leading to premature wear of internal components. Critically, it also compromises your control over the vehicle. When in gear, the engine provides natural braking assistance, which reduces wear on your brakes and helps prevent them from overheating on long descents. In neutral, this engine braking is lost, placing the entire burden on your brake system and increasing the risk of failure. Should you need to accelerate suddenly to avoid a hazard, shifting from neutral back to drive introduces a dangerous delay. Subjecting your car to hard launches by flooring the accelerator from a dead stop is one of the fastest ways to destroy an automatic transmission. This action puts immense and sudden strain on the torque converter, gears, and drivetrain. The rapid transfer of power can cause the torque converter to overheat and wear out, while the transmission fluid can degrade quickly under such extreme stress, leading to poor lubrication and potential gear slippage. The drivetrain components, such as the axles and differential, are not designed to handle the violent jolt of a launch, and repeated stress can lead to broken parts and repairs costing thousands of dollars. For the longevity of your vehicle, always accelerate smoothly and gradually. Immediately driving after starting your car, particularly in cold weather, is a habit that can cause long-term harm. When an engine is cold, its oil is thick and has not had a chance to circulate fully, leading to increased friction and wear on critical parts. This is even more crucial for an automatic transmission, as its fluid also needs a moment to reach optimal temperature and viscosity. Driving with cold, thick fluid can cause rough, jarring shifts and place significant stress on the transmission's hydraulic system, ultimately reducing its lifespan. Allowing the engine to idle for 30 to 60 seconds is sufficient for the fluids to warm up and circulate properly. Letting your car idle in drive for extended periods, such as in heavy traffic or at a long red light, creates unnecessary strain. When in drive, the transmission is engaged and constantly trying to propel the car forward, held back only by the brakes. This conflict can cause the transmission fluid to overheat, reducing its ability to lubricate and cool effectively and leading to premature wear. At the same time, it places constant pressure on your brake system, accelerating the wear of pads and rotors. For safety, if your foot were to slip off the brake, the car would lurch forward. If you are going to be stationary for more than a few seconds, it is better to shift into park or neutral and engage the parking brake. Resting your hand on the gear selector while driving can cause unintended damage. The selector is connected to the transmission's control linkage and even light. Constant pressure can cause premature wear on the delicate bushings and internal mechanisms. Over time, this can lead to looseness in the linkage, resulting in imprecise shifting or improper gear engagement. To maintain control and prevent unnecessary repairs, both hands should remain on the steering wheel unless you are actively changing gears. Shifting modes while the car is in motion, such as moving from drive to reverse before coming to a complete stop, delivers a severe mechanical shock to the transmission. This forces the internal clutch packs and bands to absorb extreme stress, causing rapid wear and potential failure. The most dangerous version of this mistake is shifting into park while the vehicle is still moving. The park mode engages a small metal pin called a parking pawl, which is designed to lock the transmission of a stationary car. Forcing this pal to engage against rotating components will likely cause it to break or shear off, potentially leading to catastrophic damage inside the transmission and an instant, dangerous locking of the drive wheels. Failing to use the emergency brake, also known as the parking brake, puts the entire weight of your car onto the small parking pawl. Over time, especially when parked on an incline, this constant stress can weaken or break the pawl, creating a serious safety hazard if your car were to roll away. The emergency brake is designed to hold the vehicle's weight mechanically, taking the load off the transmission. Always engage the emergency brake before shifting into park to protect your transmission and ensure your car stays securely in place. Allowing water to enter the transmission is one of the most destructive things that can happen to your car. The transmission is a sealed system, and if water gets inside, typically from driving through deep, standing water, it contaminates the transmission fluid. Water destroys the fluid's lubricating and cooling properties, which leads to overheating, internal corrosion, and catastrophic failure of gears, clutches, and other critical parts. The cost to repair or replace a water-damaged transmission can be immense, so it is crucial to avoid driving through water deep enough to reach your car's undercarriage. Using 2 feet to drive an automatic car is a hazardous practice. It creates a significant risk of pressing the brake and accelerator pedals simultaneously. This action sends conflicting signals to the vehicle's control systems, places the transmission under extreme strain, as it tries to move the car while the brakes are fighting against it, and causes the brakes to overheat. Overheated brakes can suffer from reduced effectiveness or complete failure in a critical situation. For safe and precise control, always use only your right foot to operate both the accelerator and the brake. Finally, avoid the common mistake of overfilling your gas tank. When the fuel nozzle clicks off, the tank is full. Attempting to squeeze in more fuel can cause the excess to spill into the evaporative emission (EVAP) system. This system, including its charcoal canister, is designed to manage fuel vapors, not liquid fuel. Flooding it with gasoline can cause damage that leads to poor engine performance and check engine light warnings. This erratic engine behavior, in turn, puts unnecessary stress on the transmission as it struggles to compensate for fluctuating power, contributing to premature wear. Stop fueling when the pump clicks off to protect your car, AES complex systems, and avoid wasting money on spilled fuel. What you are about to read delves deeper into the mechanical and digital soul of your vehicle. These aren't just tips. They are revelations about the intricate dance of physics, chemistry, and computer science happening every second you are behind the wheel. The manufacturers assume you'll never know these truths, and the repair shops profit from that ignorance. This is the forbidden knowledge that separates an average driver from a true automotive custodian. Let's begin with the silent killer we call low fuel. The idea of the fuel pump overheating is just the tip of the iceberg. The real, hidden danger lies in what this overheating does to the pump's internal components on a microscopic level. The pump contains an incredibly precise impeller that spins at thousands of RPM. When it's starved of the cooling effect of gasoline, the clearances between the impeller and its housing, clearances measured in thousandths of an inch, begin to shrink due to thermal expansion. This creates microscopic scoring, a gradual grinding that sheds metal particles into the very fuel line it's supposed to protect. These particles, now flowing with the last remnants of your gas, act like a sandblaster to your fuel injectors. Modern GDI, gasoline direct injection, systems operate at pressures exceeding 2,000 psi. At these pressures, a single metal fleck from your dying fuel pump can permanently damage an injector nozzle, leading to poor fuel atomization, power loss, and a cascade of engine misfires that the car's computer will struggle to comprehend. So, you're not just risking a pump. You're risking a complex and expensive fuel delivery system that is the heart of your engine's efficiency. Now, consider the seductive but treacherous act of coasting in neutral. To the car's central computer, this is an act of betrayal. Your Transmission Control Module, TCM, and Engine Control Unit, ECU, are in constant, high-speed communication, sharing data on everything from throttle position to wheel speed. This allows the transmission to anticipate your needs, pre-selecting gears for a seamless experience. When you abruptly shift into neutral while moving, you sever this critical data link. The TCM is now flying blind. It knows the car is moving, but it has lost its connection to the engine's power and speed. When you decide to re-engage drive, the TCM is forced to make a panicked calculation, often resulting in a violent engagement of the wrong gear set. This is the jarring clunk you feel, a mechanical shock wave that sends immense stress through the clutch packs and planetary gears. Furthermore, the transmission's internal oil pump, which provides the lifeblood of hydraulic pressure, is driven by the engine's input shaft. At idle, in neutral, its pressure drops significantly. Re-engaging drive at speed demands a sudden spike in pressure that the pump struggles to provide, momentarily starving the internal clutches of the fluid they need to engage smoothly. You are essentially forcing a mechanical handshake with a limp wrist, causing friction and wear that will accumulate into catastrophic failure. The most damning secret of all? Modern engines with deceleration fuel, cutoff, DFCO technology, use zero fuel when you coast in drive with your foot off the pedal. In neutral, the engine must burn fuel to maintain idle. You are therefore actively wasting gasoline while simultaneously destroying your transmission. The adrenaline rush of a hard launch is a direct assault on the most sophisticated component in your drivetrain, the torque converter. Think of it not as a solid connection, but as two fans facing each other inside a sealed, fluid-filled donut. One fan is connected to the engine, the other to the transmission. A hard launch is the equivalent of instantly turning one fan to 5,000 RPM while the other is at a dead stop. The resulting fluid shear is so violent it creates an immense, instantaneous spike in heat. This heat is the sworn enemy of transmission fluid, ATF. ATF is filled with crucial detergents and friction modifiers. Extreme heat causes these additives to literally cook, breaking down and forming a sticky, caramel-like varnish on every internal surface. This varnish clogs the microscopic channels of the valve body, the transmission's hydraulic brain, causing solenoids to stick and shifts to become erratic and harsh. You are, in effect, giving your transmission's circulatory system a fatal case of high cholesterol. This is a slow, agonizing death for the transmission, one that begins with a slight shudder and ends with a complete refusal to engage any gear at all. Driving off with a cold engine is like forcing a world-class athlete to sprint a 100-meter dash the second they wake up. The harm goes far beyond thick oil. Your engine and transmission are composed of different metals, aluminum, steel, magnesium, all of which expand at different rates when heated. Engineers have painstakingly designed these components to fit together with perfect clearances at operating temperature. When you drive hard on a cold engine, a steel piston is expanding faster inside an aluminum cylinder that is still relatively cold and contracted. This difference in expansion rates eliminates the microscopic oil film that should separate them, causing direct metal-on-metal wear. It's an invisible process that slowly scours your cylinder walls, leading to oil consumption and a loss of compression over the car's life. In the transmission, the electronic solenoids that direct fluid flow are calibrated to work with fluid of a specific viscosity and temperature. Cold, thick fluid forces these delicate solenoids to work harder, leading to delayed, jarring shifts that send shock waves through the drivetrain. That first minute of gentle driving isn't just a suggestion. It is a fundamental requirement for mechanical sympathy. The habit of idling in drive for long periods is akin to slow cooking your transmission from the inside out. While you sit with your foot on the brake, the torque converter is in a constant state of stall. The engine side is spinning, churning the transmission fluid, while the transmission side is held stationary. This continuous churning generates an incredible amount of heat, with no airflow to help the transmission cooler dissipate it. The fluid temperature can skyrocket far beyond its safe operating limits. This thermal breakdown of the fluid is the #1 cause of automatic transmission failure. The fluid loses its lubricating properties, and the internal clutch plates, which rely on that fluid for both cooling and engagement, begin to glaze and burn. Modern cars try to combat this with auto-hold features or aggressive start-stop systems precisely because engineers know how destructive this habit is. By holding the brake in drive, you are actively fighting the car's own self-preservation instincts. The seemingly innocent act of resting your hand on the gear selector is a form of electronic interference. In many modern cars, the shifter is not a simple mechanical lever. It's a sophisticated electronic switch that sends signals to the TCM. Even the slight weight of your hand, combined with road vibrations, can cause the internal contacts of this switch to constantly jiggle. The TCM may interpret these minute phantom signals as a pre-command for a shift, causing it to prime certain hydraulic circuits or solenoids unnecessarily. You are creating a state of constant electronic noise, which over thousands of miles can lead to premature wear of the selector's position sensors. This can manifest as the car failing to recognize it's in park, or a delay in engaging drive or reverse, a ghost in the machine that you yourself created. Attempting to shift to park while the car is moving, even at a crawl, is an act of pure mechanical violence. The parking pal is a small, hook-shaped piece of hardened steel. When you select park, a mechanism attempts to engage this pal into a notched ring on the transmission's output shaft. This system is designed to lock a stationary object. Forcing it to engage a rotating one is like trying to stop a spinning industrial fan by shoving a screwdriver into its blades. The result is a horrifying sound, a rapid-fire series of metallic clicks as the pal bounces off the spinning teeth, followed by a sickening bang as the pal either shatters, breaks its mounting pin, or rips the teeth clean off the ring. Metal fragments are now sent circulating through your transmission, where they will systematically destroy every bearing, gear, and clutch pack they encounter. It is one of the single most destructive actions a driver can take, turning a multi-thousand-dollar piece of engineering into a boat anchor in a fraction of a second. The pervasive failure to use the parking brake stems from a fundamental misunderstanding of its purpose. It is not an emergency brake. It is a parking brake. Without it, the entire weight of your vehicle, 2 tons or more, is held by the tiny parking pal we just discussed. Imagine hanging a grand piano from a single thumbtack. That is the mechanical reality of parking on a hill without the brake. The immense and constant pressure on that small metal pin leads to stress fatigue and deformation. The loud clunk you hear when shifting out of park on an incline is the sound of the pal being violently released from under this immense load. The correct, professional procedure is the mark of a truly knowledgeable driver. Come to a full stop, keep your foot on the main brake, shift into neutral, firmly engage the parking brake, then release your foot from the main brake to allow the car's weight to settle onto the brake shoes, and only then shift into park. This sequence ensures the parking pal simply slides into place with zero load on it, preserving it for the life of the vehicle. Finally, let us expose the myth of using 2 feet. Modern cars are equipped with a non-negotiable safety feature, the brake throttle override system. This system's sole purpose is to electronically cut engine power if it detects that the brake and accelerator are being pressed simultaneously. A 2-footed driver, especially one who rests their left foot on the brake pedal, is in a constant, subconscious battle with the car's own brain. They apply a little gas, but their other foot is applying just enough brake pressure to activate the brake light switch. The ECU sees this and cuts engine power. The driver, confused by the lack of response, presses the accelerator harder. The car lurches. This digital conflict confuses the transmission's adaptive learning algorithms, which are trying to learn your driving style to provide smooth shifts. Instead, it receives chaotic, conflicting data, resulting in poor shift quality and unnecessary wear. You are also generating immense heat in your brake system. glazing the pads and warping the rotors, all while sending your car's digital mind into a state of perpetual confusion. It is, without a doubt, the most inefficient, mechanically unsympathetic, and dangerous way to operate an automatic vehicle.